Uh, all right. So, quick introduction to Hasura for those of you who are not familiar with the company. We are about 180 people all over the world, HQ in San Francisco. Um, Lots of adoption from developers that has led to fairly serious mission critical deployments across large companies for fairly interesting workloads. Our customers include the leaders in the largest SaaS company, the largest social media company, the largest healthcare company, the largest consumer electronics company, the largest bank, and so users and customers can include a fair spread of use cases, um, and and we've seen a fair amount of impact that Hasura has kind of provided at scale as well. For across over 1,000 developers, being able to roll stuff out into production for applications where a minute of downtime would result in a revenue impact of over $1 million, compressing that kind of time frame from a year, 2 years to under a quarter. With kind of working with users and customers over the last several years, and especially in the context of our next generation product, one of the things that was kind of top of mind when we were thinking about this transition was how to think about making multiple teams productive, which is, of course, kind of that same topic in conversation that comes up when we think about monolith to microservices, right? And so in that context, uh, we started talking a lot about the Supergraph, and that's kind of what I want to introduce you all to. So, monolith to microservices, right? Let's say, for example, we have you're using Hasura today, or you have built your own API with Rails or Django or Java Spring Boot, and your API that encapsulates a particular domain um, probably has one or more data sources that it wraps over and provides that capability and kind of domain API to different kinds of products, to different kinds of consumers, right? Maybe they're internal apps, maybe they're developers, maybe they're external applications, maybe they're partner APIs, right? That's kind of the situation um, you might start with. Now, what happens over time is that we realize that, hey, we kind of want to do more here, right? We want to add more features. We are scaling up in not just our use cases, but even our kind of infrastructure usage is we're going from hundreds of requests per second to hundreds of thousands of requests per second, going up to say millions of requests per second. And when we kind of start seeing that dramatic increase, or in infrastructure usage, the challenge that we run into is that our system does not scale, right? It does not scale for both complexity, where we want to do more, it might not scale from a usage point of view. And so that, when we kind of start to unpack that a little bit and understand what is the human problem and what is the technical problem that will allow us to scale this, we reach for microservices, right? And there's a lot on the internet about microservices, and microservices are overkill, and we should all do monolith because Facebook has a monolith, and all of those kinds of things, which is and so I'm not going to comment on that, but the way that I summarize that entire discussion on the internet is microservices are so far the one of the best ways that we have, that is one of the most practical ways that we have, that allow us to do two things. One, it allows us to kind of decouple two teams so that they can innovate faster, right? So you have one team and you can say, hey, you do stuff and you build features, and whatever you do is not going to affect what this other team is doing and the way that they're building features, right? If you're working in a monolithic code base, somebody else does something and they screw up, that affects your work that you might be working on, right? Both from a bugs and features point of view, but also from a performance and infrastructure usage point of view, right? You have shared memory, right? And that causes issues. So you want to kind of decouple teams so that they're individually accountable and can both rapidly innovate, right? And that's kind of one part of the problem. The second part of the problem is a little more technical in that fundamentally all scaling challenges end up being data challenges, right? So if you're saying that put my writes are not scaling, my reads are not scaling, a particular kind of query that I have is not scaling. Essentially, what is actually not scaling, right? Assuming that you're an expert kind of API developer, you've built the best APIs, you've done all the stuff in the middle. Ultimately, what is actually not scaling is your data layer, right? And there, what we've also learned is that there is no one database that is going to do everything forever. And so the only way to deal with scale is to start thinking about separating out the data layer, um, and separating out our workloads, right? So we're going to take this kind of workload that is more transactional and keep it here. We're going to take this kind of workload. This is more time series. We're going to keep it here. This is real-time analytics. We're going to keep it here. This is event stuff. We're going to keep it here. So that's separating out those workloads. And that again kind of works well with microservices in a sense that each team can now choose what their best data workload or what their best data source is, on which they'll build a particular part of the entire domain, right? So those two kind of uh, things become possible where we can decouple our teams and we can separate out our data layer, so that we can handle more complexity, we can build faster, and so that we can even scale vertically or scale by usage, in a more easy way, right? The challenge, however, when you do this is this problem of solving the microservices problem, right? Where you say, I want to decouple teams and I want to have a separate data layer. The challenge is that our customers don't care. Our API consumers don't care. They're like, this is your problem. You have to figure out how to scale your teams and you have to figure out how to scale your data layer, because we just want to build an integrated experience, and we want to make sure that we can build an application or a product or an app or a API that is quote unquote web scale. And if you are separating it out into multiple domains, I'm probably going to access multiple domains, right? If I'm showing users, I'm going to have to show addresses or recent transactions that's coming in from somewhere else, right? If I'm showing you inventory data, I'm maybe pulling in brand catalog information from somewhere else, from a content system, right? And not the transactional inventory system, right? And so the API experience for products who are building things, they still want an integrated experience. They want to be able to, they have certain expectations from the API. They want consistent expectations from the API, right? They want like, hey, here's the API, and if it's working, if it's low latency and it's going to work in a particular way, it's going to have errors returned to me in a particular way. I'm going to have pagination happen in a certain way. I'm going to have uniform expectations across everything, right? That's what I would want, right? Um, and when we kind of start splitting into microservices, we're not able to provide those kinds of guarantees to the teams that are actually using the API and using the domain, right? Um, in inside your organizations, especially in enterprise, you'll kind of have a few strategic initiatives, most probably, that are going to intersect and talk about this problem, right? So you'd have like a microservice transformation effort, a microservices foundation that you're setting up inside the company. You're figuring out how many layers of microservices, the services you want to have, right? Domain APIs, process APIs, capability APIs, experience APIs, and stuff like that. Um, Another place where this similar kind of conversation comes up is with data mesh and data products, where you're thinking about, oh, I have data that is in different places, but ultimately I want it all to kind of come together. And I want to create these multiple data products and have them come together and be a single data product, right? You want to de-silo. You want to silo, and you siloed first, but then you want to de-silo as well. Increasingly with things like Gen AI and whatnot, this is again a discussion that will pop up from whoever in your organization is, the folks who are experimenting with Gen AI and trying out things. One of the first things they'll run into is, well, I need data from multiple places, and that's just not available to me, right? How do I access that? How is that secured? All of that needs to happen. So this problem where we separate it out into multiple domains, into multiple microservices, meets reality. Reality is customers and consumers and applications that want a shared experience, that need to access multiple things, and it creates this tension, right? This tension is not new. This tension is age old, right? This tension of saying, let's decouple things to make it move faster, but let's de-silo things so that we preserve sanity, right? So that we know what's happening. Like we have to, this is the tension that plays out everywhere and has been playing out for a long, long time, right? How can we separate things to make it move faster? But at the same time, how can we get a unified view so that it's in one place and makes things easy, right? Cognitive overload is lower. Now, we know that providing that this access to these different domains is challenging, right? There's this kind of spaghetti crisscross problem. We have to make sure that each of those domains are building APIs. The APIs are standardized. Uh, the way that we do pagination here has to be similar to the way that we do pagination here, so that it doesn't break the developer's brain who's kind of trying to consume these APIs. And they're like, yeah, cool, you're doing pagination with this kind of standardization and you're doing pagination like this. And, thank you for nothing. I hate this experience of trying to integrate those APIs, right? The domain owners also have to make sure that they're preventing drift, because this domain is continuously evolving. The domain APIs that they're providing, they might go out of sync, right? The documentation, the API specification, the API implementation, and the underlying sources, right? All of these have various layers of models and documentation, and any of them might go out of sync with each other. That work sucks, right? So that's important, and that's a problem at this level. But then when all of this has to come together, you have this data integration and orchestration challenge, right? Where all of these APIs have to kind of come together. We need a centralized registry. There is this product is building a product API that is going to be used by say external developers or by other teams. That needs to fetch data from here and here. They're doing some integration work, but this app is also doing integration, the same integration from data that's coming from here and here, right? So the same kind of munging and data integration is happening again and again. This is time consuming at an organizational level, but also very error prone, because the challenge becomes that if there is a bug somewhere or something has gone wrong, especially from a data integrity point of view, right? You don't know why that's wrong, right? When you tried to join two pieces of data and you got null. Is that null because of an error between two systems, or is that null because one thing is genuinely null, right? The data itself is null, or is it because it's not accessible? And that's why I'm kind of getting a null here, right? And everybody's kind of implemented that logic in a slightly different way. If everybody's kind of duplicating that, right, starts becoming fairly challenging. And then, of course, all of these various APIs have to be kind of documented centrally somewhere so that it's easy to discover and what is happening, right? That's so we know that microservices will be helpful in decoupling things, but then we also know that there's a fair amount of work to do, because we took the problem that we would have had with a monolith and an API, and we essentially multiplied that, right? So the same work that we would have to prevent drift and to maintain the API schema and standardization conventions, now we just have to multiply that with every single team. And the work that needs to happen, that is potentially duplicate effort with data integration orchestration that could have been easier to put inside a monolith, now needs to happen somewhere, or is potentially being duplicated wherever it is, right? Now, in this context, is where we're going to introduce the Supergraph. Now, this before we get into this, the interesting thing is when you're thinking about this problem again, because it's not a new problem. In the older version, in the older world, pre-microservices, also the same problem existed, where we had silos and we had technologies like ESB and iPaaS that we used to use to kind of think about this layer. In a microservices context, when we're using microservices, we're thinking about API gateways to kind of do this. And then in a GraphQL context, we're thinking about like, hey, let's have little GraphQL servers that can then go into a GraphQL gateway, right? So that's kind of been the some bits of the evolution over the last few years and how we've been dealing with this problem. So what I'm going to talk about is a Supergraph, which is a GraphQL inspired way of thinking about things, and then introduce kind of what work we're doing on that front. So the Supergraph. Now, At a very high level, the idea is each of those domains is a subgraph, and they are automatically unified into a supergraph, right? And so what we really want to do is those challenges that we talked about that were crisscross challenges with lots of pain points at both the subgraph or the microservice level and the integration level. How much of that work can we make? How much of that can we get for free? How much of that work can we get without any human intervention, without any extra work being done by anybody in the organization? Um, how do we kind of approach that, right? And so the first idea is that if we can start thinking of each domain as a semantic subgraph, right? Because ultimately everything inside your organization is a semantic graph, right? We're not talking about graph databases. We're not talking about graph traversals and graph searches or graph analytics at all. What we're talking about is the idea that there is an entity graph, right, of whatever exists inside the domain. Even if things are not related at a top level, it's a graph of unrelated nodes and unrelated models, right? This notion that each domain that we have is a subgraph, and the subgraph makes it easy for us to understand what's happening inside a domain, and provides a way for us to access and query and make API calls to that domain. If that becomes easy at a subgraph level, then technically just multiple subgraphs coming together into supergraph would make it automated at the multiple team level, right? And what that would allow us to do is to get the kind of registry of the entire org-wide or across these multiple domains, our entire kind of graph for free, so that we understand what is happening. We understand where what information is. We understand how we can access all of this information. And instead of maintaining that API endpoint registry, we could get this registry for free as these domains evolve. If our graph provides us a way of accessing data that is related at the subgraph level, then at the supergraph level, we should also be able to do that, which means that this data integration and orchestration work that's happening is also available for free, right? It's also something that we get for free. I'm going to dive in a little bit into kind of the for freeness of it and what it means from a GraphQL point of view. I'm assuming that most of us here are familiar with GraphQL and with Hasura a little bit. So I'm going to breeze through it, but it'll be useful context, I hope. So let's imagine that we have this e-commerce like domain, and I have three subdomains, right? Or three subgraphs. I have users and address, user information, order inventory information, and catalog and product catalog information, right? Three subgraphs. They're all obviously related to each other. And the first bit of when we say graph, and we zoom into GraphQL in particular, we start thinking about letting our API consumers access whatever data they want, right? So instead of us maintaining endpoints for each particular shape of data across those domains, what if we can get a way to query that, right? To query users and address in a single API call, a single in a single fetch, but letting that end user decide what part of the data they want to fetch. And if you're able to do that across not just within a subgraph, but if that can scale across these subgraphs, well, that's great. And we get kind of this data integration piece for free. So I'm able to fetch a user and the address, but I'm also able to fetch the user and their most recent orders, and for each order, some product item information in a single API call. So that's nice. I get that ability, and that makes that data integration work happen for free. The documentation of the number of domains that I have and each of those API endpoints that I have, instead of looking at something that is a set of API endpoints, I can now look at it as a set of entities that are related to each other. Understanding a list where I have different kinds of endpoints which can do different things, versus understanding that I have a graph that I can read data from, and there are commands that I can run which will trigger workflows or mutate this graph or change the data inside this graph, is much easier to understand, especially if I can start building an intuition for the way I can read from the related part of the graph, right? So if I know that there are certain ways that I can paginate and read and join, that makes life really easy, because now I can, as a consumer, as an API consumer, I can kind of look at this and be like, oh, okay, cool. I should be able to make a request to get user dot orders and order dot like top 5 products, or the most expensive products that were a part of this order. That should be possible. Um, and I can build that intuition very quickly instead of having to read every single endpoint and what the documentation for the endpoint is, right? And that's kind of the irritating part of the documentation work that we have to do, that becomes available for free because you have a semantic graph. The burden of this idea of having a subgraph and then having subgraphs become a supergraph is few obvious pain points, right? The first is we have to build a subgraph. We have to convert this domain into a subgraph, right? The subgraph has to provide a way of um, accessing the graph of information, say over a GraphQL API that we just looked at, right? And that work needs to be done. Is that going to be a new microservice? Is that going to be a new service on top of our existing microservice if we have one, or on top of our database, or whatever it is? That has to be built. And so we have to kind of build this additional layer potentially, right? Which is a pain. The second is, it's great to have this large blue box here called Supergraph, but that's kind of back to just the monolithic world, right? Is this a single point of failure and performance all over again? What did we really achieve, right? We did achieve something. We separated out our data workloads, right? If we transition from monolith to this, we achieved a unified API, but we also created a single point of failure and a performance bottleneck potentially, right? Where now this supergraph thing that is routing queries to different systems is now a new bottleneck, right? Somebody has to operate it, somebody has to go peek inside it and see what it's doing. And now there's more dev and more ops to do at this layer, right? The third piece is that in the way that we just talked about subgraph and supergraph over the last few minutes, we talked about from a GraphQL point of view. And so that means that the API that we're providing here is a GraphQL API. That is that kind of sounds like a not a very 2023 thing to do, right? Because you might have situations where the data that you're accessing from this conceptual supergraph, you have you want to get real-time information, so you really like the idea of subscriptions, but you don't want to get it over WebSockets. You want it delivered over webhooks, or you want it delivered over Kafka. You don't like GraphQL as a protocol between these two. You want it to be efficient, and you want it to be over a binary protocol with HTTP2 or with HTTP3 or whatever it is, right? That's a problem, right? Because if you're investing in kind of this layer in the middle that's going to do things, if this layer enforces a particular API protocol that you're going to have, that's a lot of work. We just built subgraphs, and then on top of these subgraphs, we put in a supergraph, and everybody's using a GraphQL API. And now what if we want to move away from GraphQL, right? And so there's that kind of burden. And for some of you who've been using GraphQL or champions of GraphQL inside the organization, that might be one of the challenges that you frequently run into, right? Where somebody says, yeah, I don't know about GraphQL. I feel like gRPC is just going to be much faster, right? You benchmark it and you're like, gRPC is much faster because it's HTTP2 and it's a binary protocol, right? It's not HTTP and JSON being chucked at each other, regardless of what is happening underneath it, right? So that's kind of the burden of introducing a supergraph. This is where we found ourselves a few months ago, earlier this year, and we were thinking about, well, how do we make this happen? And how do we change the arithmetic and the economics of development of a supergraph? And how do we address these kind of fundamental issues? What principles do we create? What product capabilities need to exist to solve this problem without introducing excessive lock-in, without introducing a single point of failure, without introducing an excessive burden on somebody, right? On the domain owner who has to create subgraphs, or on people who have to use the API. What should we do? And that kind of brings us into our next gen version of the product, which is called Hasura DDN. We call the Hasura Data Delivery Network. We like to think of it as a fabric, like a CDN, like an infrastructure fabric that you can run in your enterprise, or that you can run on our hosted solution, powered by our new Hasura engine, the Hasura V3 engine. And the way that we started to think of this was a little bit different, of saying, instead of thinking of Hasura as a point solution that provides APIs on a particular data source, what if we change the way we think to, I own a particular domain, maybe I own a microservice, I own a data domain, I own a data source, and I'm going to connect that to the DDN. And the DDN then will do some simple, obvious, but reliable things to provide a supergraph to my consumers. And as a domain owner, all I think about is, here's my domain, I connect it to the DDN, and I'm going to get a supergraph on the other side, right? And that's kind of the way that we change the way that we're thinking about it, right? For those of you familiar with Hasura, before this, the way that we would think about Hasura as a point solution, where you think about, hey, let me put Hasura on top of data source, right? Put Hasura on top of a domain and get an API. And this is different, right? This is thinking of it as a piece of infrastructure where you connect your data into that DDN and see what happens. So let's dive into what that looks like. Same blue box called Supergraph, which now changes to Hasura Data Delivery Network, which is the operational fabric that provides the supergraph. And you notice that the subgraph has changed into a connector, which is the thing that connects a domain into the DDN and provides the subgraph on that domain. Right? So the connector provides, connectors provide a subgraph, and those subgraphs then get joined by the DDN into a supergraph. Right? Let's think about kind of like, what is required to help make this a long-term feasible investment, and making supergraphs a feasible investment without kind of being able to get those benefits, but without having to worry about all of those problems that we just talked about, right? The first piece of this is thinking about the operational layer of the graph, of the thing that processes graph queries, or the thing that creates a semantic graph, the DDN itself, as a distributed serverless runtime, right? And so that's kind of been one of the core parts of the work that we've done, where, and we'll be open sourcing this work soon, but from a graph point of view, our parser that can parse a GraphQL request into anything else is the fastest GraphQL parser in the world. It is 4x to 5x more performant than anything else out there. We'll be open sourcing it sometime soon in the next few weeks, as we open source our V3 components. This powers that engine, and that just one part of the engine, which is the parser. There's the other part of the engine, which has the semantic layer and processes it into queries and stuff like that. But those pieces are built to be distributed and serverless from the get-go. And so that means that for us, this layer on our public cloud is multi-region. In the future, we want to go towards multi-cloud, but multi-region from the very beginning. That allows us to be in several edge locations all across the world from the get-go without any extra effort. Each part of whenever a request is processed is a Lambda unit, which means that when you think about limitations, about scalability, the speed at which you can auto-scale or scale down, concurrency and tenancy, it becomes much easier to kind of think about it from a Lambda unit point of view. And each of them are completely decoupled from any other execution that's happening at the same time. It's like kind of a serverless function, right? Where you know that if this particular API call is heavy or fails or slow, it's not going to affect what something else and what another API call is doing. And that is what kind of prevents this from becoming a single point of failure or a single point of a layer that becomes a performance bottleneck. The second piece, and we kind of laid the foundation for this a little bit last year and the year before that, where we want to start thinking about decoupling graph from GraphQL. The idea of a semantic graph that allows you to understand how things are related to each other, but the protocol in which you access the graph and query it, we want to decouple those two. So that means that you get a graph abstraction, you get the ability to make a GraphQL query if you want that fetches data across multiple things. But the actual API protocol that you might want to use to provide that access to an end application API or developer can be REST. We're working on gRPC, which should be available sometime next year. We're working with some enterprise customers to make it possible over webhooks and Kafka as a delivery mechanism. So this protocol is actually Kafka, particularly for subscriptions-heavy workloads. But decoupling that makes this a viable strategic investment, right? So you can getting your cake and having your cake and eating it too, right? Because now you're saying that, well, this semantic layer, this ability to access stuff is great, and I can choose whatever protocol I want. Not sure about whether we should do SQL or not as well. It's been something that we've been thinking about. It's something that kind of pretty excited about thinking about, well, what if this was actually a SQL API on top of different services? Wouldn't that be cool? And so, yeah, but that's very, very far in the future, twinkle in our eye for now, right? So right now we're thinking about GraphQL, REST, gRPC, and some protocols for real-time events beyond WebSockets, webhooks, and Kafka in particular. The third is the piece that helps create the subgraph on each domain, right? Learning from what we've been doing with Hasura when we connect to various databases and the way that we brought in other external APIs and services, right? Taking our experiences, learning from that and making that kind of more systematic and changing the way that we think about it is a set of connectors where the connector helps you connect your domain, right? And connect that to the DDN. And so the creation of the subgraph is automated. And that automation, those guarantees, whether it's performance, whether it's scalability, whether it's drift, the API contracts that are managed, the API drift problem, and the reverse of that, which is the API contracts, can we automate that so that there is zero cognitive overload on the owners of a particular domain, right? Can we get that quote unquote for free so that this doesn't feel like a heavy investment or even a lock-in, right? Because ultimately you control your domain. So at any point of time where you feel like, hey, I can't access through the Supergraph. I have a tactical challenge or a long-term challenge, and I need to access the domain directly. You always can. You're going from the domain into the subgraph and into the supergraph that you want. Talk about three principles here that are critical. The first principle is domain driven, right? We kind of talked about the connector being able to automatically create a subgraph from that data source or from a microservice. We want domain owners to continue work on their domain without having to dev and ops another layer. That part is critical. We don't want to build another API. We don't want to build another GraphQL API or another gRPC API if we already have one. We don't create layers of wrappers and wrappers and wrappers and wrappers, right? Like we don't want to do that. Want to do better things with our lives, right? And the way to solve for that problem is what we created was, we call it the NDC specification, the native data connector specification. And that is a specification that allows us and anybody to build a connector that can provide a systematic abstraction on top of any domain and help convert that into the building blocks of a subgraph. That means that, for example, if you have databases that have query languages, we have a connector for that is able to provide that can process graph queries on top of an underlying database. So if you're using Postgres, we'll be able to kind of understand their lateral joins that we can exploit here. If you're using a database like, for example, MySQL that doesn't support rich join functionality, we'll be able to make multiple API calls or multiple DB calls using Mongo, compile that to an aggregation pipeline. That is the best for Mongo, right? But that ability to efficiently create a graph query or to process a graph query, an input that requires data to be fetched multiple places, predicate push down for how authorization is enforced, validation is all done at this connector layer. So this connector layer can also connect to OpenAPI or gRPC or anything that has a schema that can be used to derive a subgraph. Inside your organization, you might realize that the way that you're using a particular database or the way that you're using OpenAPI, you already have standards that you've created across these domains. So you've already standardized the way that you're doing data modeling, or you've already standardized the way that you have REST APIs, and they're already standardized. They're all lovely OpenAPI spec with the way that you're doing filtering and pagination, and all of that is already there. What the connector abstraction allows you to do is build a custom connector for your teams that converts your OpenAPI into a standardized subgraph in the same way across all teams. So you can build that connector once, you can call it like the MyOrg connector, and MyOrg connector is your subgraph creation and automation technology, right? That can map your domains that are standardized because you've already created that standardization, say, into the right subgraphs that you have. So that's kind of this one-time investment that can then scale across multiple teams. Sometimes you might have a complex ERP or legacy system that you want to bring in as a subgraph. In those cases, you can always build your own connector, work with our team. We're starting to build out a professional services team to work with our enterprise customers to help them build connectors for the tremendous amount of legacy data and legacy sources and legacy services that they already have, and kind of help bring that to the rest of the organization. The most important thing about the connector is that it's integrated into the SDLC of that particular domain. So that means that as you evolve your domain, as you change the schema of your database, or as you change the schema of you're building a microservice that exposes like a proto contract as a gRPC service, or has an OpenAPI JSON schema type situation, right? As you iterate on your domain, the subgraph and the evolution of the subgraph is coupled to that SDLC. And it is possible to make sure that as you're evolving your domain, that subgraph also evolves safely as a part of your work. So there is no extra work that you're doing in maintaining another kind of, if these were subgraphs that you were building with GraphQL, in maintaining another GraphQL server and maintaining GraphQL schema, right? You're taking your expertise as an owner of the domain, your expertise as a person familiar with your data workload or your backend technology stack, whether it's Java or Python or TypeScript or whatever it is, and you're able to take that expertise and push out a graph from your domain, right? And that there is no drift and there's no extra work that you have to do to make sure that the subgraph schema stays in sync with your domain schema, right? And whatever you're using to describe your domain schema. The second, which is a critical part of this kind of creation of this supergraph, which is the single point of management, right? That suddenly becomes like, well, we were all microservices and we all got to do our own CI/CD and we were iterating quickly. Now you've created a central coordination point called a supergraph. And if I do something, for example, my API returns IDs as strings, somebody else's API, when it accepts an ID, right? So you fetch a user, and in the response of my user, I return a user ID as a string. And then someone else, where you want to fetch the address for that user, they take that ID, but they're serializing it as a number. Well, it's true, right? Somebody changes something that might not be a visible change. It's kind of slightly one of those subtle changes, and suddenly the contract for this person is broken, right? It's broken because two teams worked independently in their own way, because they should have. That's microservices, right? Everybody works on their own APIs, but it broke a shared expectation that a consumer had, right? These are tough problems, right? How do we introduce kind of this notion of saying you can have shared CI/CD? The core concept that we embraced when we were building DDN out is this idea that any change in the subgraph or in the supergraph, right, in the configuration of the supergraph or in the way that the subgraph is connected to the supergraph, in Hasura terminology, any metadata change, any subgraph metadata change or supergraph metadata change creates an immutable supergraph within seconds. And so that means that if I add a new field, I can instantly get a new supergraph URL. I'll get Tanmai dev 2 dot something 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 .api.com, right? And every single change gives me a new atomic, an immutable build that is the entire supergraph because of this change. This is this is beyond just making changes where I make a change and I get a change only for my microservice. I can make a change and actually get the entire new supergraph that would be created because of my change. And this makes it possible for me as a subgraph developer, or for a supergraph owner, or for a supergraph consumer, or for automated QA and integration testing, for all of that to become possible in a shared CI/CD environment without creating dependency between multiple teams. So you're able to kind of test together, understand how everything comes together without being dependent on other teams for each change that you make, which was the promise of microservices. What this also makes possible from an ops standpoint is every change you can start to become more fearless, right? You make a change, you got a new atomic build, like think of it as a SHA, like a new hash build, right? Um, you can roll back to a previous version if something goes wrong. You can do a canary rollout. You can do a blue-green rollout, right? And all of that is just available out of the box with this idea that every single change creates an immutable supergraph. And we're able to do this. You're able to do this even in what we call a watch mode. I don't know how many of you folks got the community call a few weeks ago where we demoed a watch mode where you can make changes live to the metadata, to the underlying database, to your TypeScript functions, and all of that is just live going into a subgraph and a supergraph. And each of those, if you want, can create immutable builds. And that is inexpensive for us at any scale, which now makes it possible for you to get those kind of atomic IDs that you can roll back and roll forward and do all kinds of cool things with, even if you're iterating on it live in kind of like this dev watch experience, which is very nice from a federated CI/CD point of view and kind of adopting a slightly more fearless mindset to rolling things out. This also means that regression testing and API breaking change prevention is also automated. This has been something that has been hard for us as well over the last few months and years as we've been kind of iterating on versions of Hasura. Hasura itself in V1 and V2 was monolithic and not serverless and distributed. And what that created are situations where where there might be something extremely specific to your workload, to your database that introduces regressing behavior. It could be a regression in performance, it could be a regression in the way that the API works. And that made it very hard for us to iterate as well, and for our users and for you to upgrade Hasura versions quickly. We've gotten because of this immutable build system, have gotten rid of that problem where Hasura version upgrades, your metadata version upgrades are now all immutable and you can switch back and forth between them, which makes it really easy to adopt new versions, to adopt new changes, and to make your own changes as you need to. The third principle is composable and performant. That's the last thing that I'm going to talk about. Composability is the heart of getting stuff for free. That's why we like GraphQL, right? The fact that you have a user model and an article model, and you can say user.articles and do all kinds of cool stuff with it. The more composable your system is, the more stuff you get for free, the less API endpoints you write. But every time you make something more flexible or composability, it's not feasible to actually roll out if performance cannot be guaranteed, right? And so that's this tension that always exists. Let's make stuff more flexible, but then you don't get performance, right? If you think about all of the SQL and NoSQL database stuff that has happened over the last few years, SQL was too flexible. So what NoSQL databases came in and said is, wait, I have an idea. Let's make it less flexible and then give really good performance, right? So that trade-off and being able to handle that trade-off is really important when we think about being composable. For us, providing that super graph and a graph way of accessing data, composability is really important, but with a way to guarantee predictable performance and with a way to optimize or improve that performance in specific situations the way that you need to. And again, that idea of being able to decouple the DDN layer from the connector layer makes that possible. Give two examples of how that works. For those of you familiar with Hasura, you would have been able to make these queries within a subgraph. Now you can make these kinds of queries across the supergraph as well. So for example, let's say you're fetching users, and for each user, you want to fetch their top 5 articles, right? This is an interesting query. This is not a straightforward, you can't do this with a data loader. Even if you had one GraphQL server with a data loader, you would not actually be able to make this query efficiently. And that's because this underneath it ends up being either a lateral join kind of situation or a window function or a CT if you're talking to a SQL database, or an aggregation pipeline if you're talking to Mongo. Because for each user, you need to fetch the articles for that user and sort it in the context of the articles for that user. So you can't do an inquiry, for example, which is what a data loader relies on when you're speaking to a database. This being able to do this in an efficient way, and then being able to do this in an efficient way when you're fetching this data from two subgraphs and from two different subgraphs, is something that we've been able to do in the way that these connectors and the query engine of the DDN itself works. This makes it possible to, in the simplest case where you have tiny limits, get 2x to 3x of performance increase. But as the number of entities that you're fetching is larger, as the amount of data that you're fetching is larger, that difference in latency that you're going to see from this kind of a query is going to start becoming an order of magnitude. It's going to become 10x to 15x in the difference that you see in the way that Hasura we are able to plan a query and a data fetch versus any other way of doing this where information is lost. So if you try to use an API gateway, you'd have to do multiple API calls. If you used naive GraphQL Federation, where you had, this is also GraphQL Federation in a way, but another form of doing GraphQL Federation is when you have a GraphQL gateway talking to GraphQL servers. The way that you're talking to independent GraphQL servers doesn't make it easy or possible to create these kinds of composable queries, because the protocol between the federation layer and the federated subgraph is also restricted to GraphQL. And when that is restricted to GraphQL, you're not able to kind of create efficient queries to fetch data from those subgraphs. Another cool example of composability that you get is the ability to compose predicates, right? And so what you can do is you can say, hey, I want to fetch articles by a property of what the article is related to. Again, for those of you who use Hasura, you would notice that you can run these within the same subgraph. Now we can do this across subgraphs as well, right? And so predicates can be composed as well, not just types, right? And so that kind of provides a very common use case, right? Both of these are extremely common use cases, and both of these are two use cases that are either extremely hard to do manually or very hard to get right from a performance point of view. And that's core to how we approach building DDN and we approach to building our connectors. I'm going to take a quick summary and then of the things that we talked about before we wait for questions. I think we just have about a few minutes left. But at its heart, the important transition that we want to help power for our users, for our customers, and for the world is helping people move and embrace multiple data technologies, or bring together the existing multiple data technologies that they already have, to federate and to allow individual ownership, best of breed choices. If you know that you can add a new feature by just bringing in a ClickHouse, or you know that you can, you have JSON data that needs to be highly available and available in several regions across the world, and you want to just reach for a system like Mongo. You want to have a high write system that is something like Cassandra. You should be able to choose the data source that you have, or the data source that you want to move to, or the underlying microservice technology or tech stack that you want to use. You should be able to do that easily without compromising on that kind of monolithic experience that is most important for your end users. And towards doing that, the work that we're doing, releasing this in beta in January and then GA soon after that, is the work that we've been doing with Hasura DDN, called the Hasura Data Delivery Network. So that is the introduction to the Supergraph from the Hasura point of view. We have a few minutes. I'll take any questions if you folks have any, but otherwise I'm always available and happy to chat on various forums, Twitter, email, whatever. Just feel free to reach out. And I always love talking to you folks about what you're doing. But I can take a few questions if there's any. Yeah, so I think one of the questions that came up was whether thinking about Hasura actions to REST APIs. Yes, that's so. What we've done with B3, and again, we demoed this in our community call a few weeks ago and the previous community call as well. Um, Hasura can have an integrated, like a connector that brings in a particular programming language as well. So the first one that we're doing is TypeScript. So what you can do is you can actually have a connector for TypeScript functions. So that means that instead of having to write a deploy a separate piece of code somewhere else and then bring that in as an HTTP API as an action in Hasura V2, in DDN, which is powered by Hasura V3, what you can do is literally just write a TypeScript function, and that becomes the action that you have. So, for example, if your TypeScript function is wrapping over an external REST API, it becomes really easy to just write one line of code that then gets and becomes a part of your schema. What you can also do is if you now know that your REST API has a particular schema, like it's already an open API, you can use our open API connector or build your own connector that brings in the whole thing as a schema into Hasura, right? So you can either write those little functions that you can manually use to shim stuff in, or you can build a connector, or you can use one of the reusable connectors to bring the entire API in. Another question on serverless and container images. Yeah, the entire Hasura system itself is built with it internally runs on containers and has a container platform for both the DDN layer and the connectors. So, for example, if you want to self-host and create like a self-hosted DDN or self-hosted connectors, it's essentially just containers that you can run. From a self-hosting point of view, there are two options. One is whether you want the Supergraph layer, the DDN layer, whether you want to self-host that or not. So let's say, for example, your data is local, your database is local or on-prem or secure or on your laptop, right? What you can do is you can run the connector locally, but keep DDN running in a multi-region way, right? So that way you don't have to run the DDN, you just have to run your connector. This is particularly useful for on-prem or complicated topology kind of deployments where you want to self-host that connector as well. So that's kind of one way of doing self-hosting. And then of course, because the DDN engine is also open source, you can take you can create a container image for the DDN layer, which is the kind of Supergraph layer, the federated layer, and you can run that and self-host that as well. But there'll be a little more like initial ops work that you'll want to do to set that up to be distributed and easy, especially if you want to get like immutable deploys and stuff like that. So there'll be a little more setup that you need to do to make that happen, but ultimately it's all just container images. So you can self-host whatever parts of this you want to. All right, I think we're at time. Thank you, folks. Like I said, please feel free to reach out to me if you have any questions. And as we gear up towards launch and release, and it's publicly accessible, we'd love for you folks to try it out, give us feedback, and chat with you folks soon. Bye, everybody.